E equals mc squared, 3 letters, 1 number, and an equals sign that changed our understanding of the universe forever. This is arguably the most famous equation in all of science, but what does it actually mean? And why did it revolutionize physics? I'm going to break it down for you in the next few minutes, and by the end, you'll understand why this simple-looking formula is so incredibly powerful. Let's start with what each part means. E stands for energy, any kind of energy. M represents mass, the amount of matter in an object. C is the speed of light in a vacuum, which is about 300 million meters per second. And that little 2? That means we're squaring the speed of light, multiplying it by itself. So the equation is telling us that energy equals mass times the speed of light squared. But here's the mind-blowing part. It's saying that mass and energy are actually 2 forms of the same thing. They're interchangeable. This was revolutionary because before Einstein, we thought mass and energy were completely separate things. Matter was matter, energy was energy, and never the twain shall meet. Einstein showed us that wasn't true at all. Now, why does this matter? It's all about that c squared. The speed of light is already incredibly fast. It could circle the Earth 7.5 times in just 1 second. But when you square it, you get an absolutely enormous number, 9 followed by 16 zeros. Let me put this in perspective. If you could convert just 1 gram of matter, about the mass of a paperclip, into pure energy, you'd get about 90 trillion joules of energy. That's roughly equivalent to the energy released by 20,000 tons of TNT, or about the same as the atomic bomb dropped on Hiroshima. This tells us that even tiny amounts of matter contain absolutely staggering amounts of energy. The reason we don't notice this in everyday life is because converting matter to energy is extremely difficult under normal circumstances. But nature does this conversion all the time. The most obvious example is right above us, the sun. Every second, the sun converts about 4 million tons of matter into pure energy through nuclear fusion. This is what makes the sun shine and provides virtually all the energy for life on Earth. Here's how it works. In the sun's core, hydrogen nuclei slam together with such force that they fuse into helium. But here's the key. The helium nucleus weighs slightly less than the original hydrogen nuclei. Where did that missing mass go? It became energy, exactly as Einstein's equation predicts. We've learned to harness this on Earth too. Nuclear power plants work by splitting heavy uranium atoms. When a uranium nucleus breaks apart, the pieces weigh slightly less than the original nucleus. That missing mass becomes the energy that powers our cities. And yes, nuclear weapons work the same way. They're just uncontrolled versions of these same mass energy conversions. But EMC2 is about much more than just nuclear reactions. It's actually a simplified version of a more general equation that Einstein derived from his theory of special relativity. The full equation is E2 equals sign, mc2 2 plus pc2, where p represents momentum. For objects at rest, momentum is 0, so we get back to our familiar E=mc2. But this reveals something profound. The equation is telling us about the fundamental relationship between space, time, matter, and energy. Einstein realized that mass actually warps the fabric of space-time itself, and energy does the same thing. This is why massive objects like stars bend light. They're literally curving space and time around them. Mass and energy are different aspects of the same fundamental reality. This isn't just abstract physics. EHMC2 has practical applications that affect your daily life. Medical PET scans work by detecting the energy released when antimatter annihilates with regular matter, a perfect demonstration of mass converting to energy. Particle accelerators use Einstein's equation to create new particles by converting energy into mass, the reverse of what happens in nuclear reactors. This is how we discovered many fundamental particles and continue to probe the deepest mysteries of the universe. Even GPS satellites have to account for relativistic effects predicted by Einstein's theories. Without these corrections, your GPS would be off by several miles. From carbon dating to smoke detectors, from medical treatments to space exploration, the principles behind ECALS-MC2 touch virtually every aspect of modern technology. Perhaps most importantly, EMC2 changed how we think about reality itself. It showed us that the universe is far stranger and more interconnected than we ever imagined. Matter and energy aren't separate things. They're two sides of the same cosmic coin. This equation helped us understand how stars are born and die, how the elements that make up our bodies were forged in stellar furnaces, and how the universe itself began in the Big Bang. It revealed that we're literally made of star stuff, the carbon in our muscles, the iron in our blood, the oxygen we breathe, all created through the mass-energy transformations that E/mc2 describes. In a very real sense, this equation tells us that we are intimately connected to the cosmos itself. So there you have it, E/mc2. What looks like a simple equation is actually a window into the deepest workings of reality. It tells us that mass and energy are interchangeable, that tiny amounts of matter contain enormous energy, and that the universe operates according to principles that are both beautiful and strange. Einstein once said that the most incomprehensible thing about the universe is that it's comprehensible. E/mc2 is perhaps the perfect example of this, a simple equation that captures something profound about the nature of existence itself. The next time you see those 5 characters, remember, you're looking at one of humanity's greatest insights into the cosmic order. Not bad for a patent clerk from Switzerland who liked to think about what it would be like to ride alongside a beam of light. If you enjoyed this explanation of Einstein's most famous equation, make sure to subscribe for more deep dives into the physics that shapes our world. And let me know in the comments what aspect of E/mc2 surprised you the most.